Greetings and welcome to the Chemistry 222 Graphing Lab, where we're going to explore techniques used to make a computer-generated graph and also utilize what's called linear regression to get really cool information out that scientists can use to predict future values of different things and stuff like that. Linear regression sounds a little ominous, but actually it's pretty chill. I'm going to try and show you how chill it actually is in this lab. It should be pretty mellow, so without further ado, let's get into it. First of all, a graph is very important for scientists, especially types of science fields and stuff that are really important. It's nice to be able to graph your data versus some kind of known variable. And on the left-hand side are examples of two different graphs that might prove useful. On the left-hand side, on the top, is some kind of amount in inches versus year. I have no idea what it is, but notice the blue points right there. If you ignore the line for just a second and focus on the blue points, you can see that they're kind of all over the place. All right, they're not very well coordinated with like a line. They might have some other kind of thing. On the other hand, in the lower left-hand corner, we have a graph that's actually going to be something we'll do in Chemistry 223 if you take it. The graph on the lower left is absorbance of a sample versus the concentration of something called FeSCN2+. We'll talk about this more in a future lab. But if you look at those dark points right there, they fall very nicely into a linear relationship. And so graphing the data shows that the lower data set is probably going to be more predictable, and the upper data set is going to be more random, harder to predict what's going to happen next. It would be nice, though, if scientists had a way to measure, say, the predictability of data. And so if you look at both of those graphs on the left-hand side, there's also an R-squared value. And R-squared is the function of a linear regression analysis. And a linear regression analysis is something that's very easy to do in a modern computer program, i.e. Microsoft Excel, Apple's Numbers, Google Sheets, stuff like that. And if you do the linear regression, that's where those lines come from in both of the graphs. And you can actually then see visually that the lower data is a great fit, while the upper data, those points are all over the place. But on top of that, a linear regression gives something called a correlation coefficient, that R-squared value. And we're going to see how that can actually be used to help show scientists that the top data is a little bit more random. On the other hand, the bottom data is a very good fit and very predictable. So it's kind of cool stuff. Now, on the lower right-hand side, we have a picture there of diamond price versus carat weight. And you can see how more or less it's kind of increasing up and to the right. So there is a linear relationship, even in things like diamond price. It's more than just science, okay? I'm trying to point that out. Scientists use this a lot, but it's also used in economics, and it's used in medicine. It's used in lots of different fields that you wouldn't think about. So being able to graph data is an important part for science, definitely. And that's what we're going to be exploring in this lab. And if you can couple it with a linear regression to see how linear your data is, that's also pretty cool and very useful to chemists and scientists in general. So we'll see all these kind of things in this lab and talk about it. Linear regression is sometimes added into a math curriculum, but they don't really talk about, in my opinion, like how useful it is. So I'm going to try and give you a scientist's interpretation of linear regression, and hopefully it will help. If you have two variables, for example, distance and time, or number of Diet Cokes consumed versus day of the week, I mean, there's any kind of variables, the data can exhibit linear behavior. Now, it doesn't always exhibit linear behavior, but there's a lot of examples where it does. And so if your data has linear behavior, and you can see in the graphs in the lower left there, A and B are definitely linear. They're nice straight lines, all right? C is like very random. I don't see any correlation in that at all. D is a curved line, and there are other kinds of regression analysis that we could apply for that. So we're only going to be looking at data that follows kind of a line, all right, when you graph it out. And if you do have a linear set of data, you can use almost any current spreadsheet program, Microsoft Excel, Apple Numbers, which is for free on the Macs, and Google Sheets is great too. Any of these kind of things, plus most of the TI calculators will do a linear regression for you. A linear regression is literally just putting the X data in and then the Y data in and pushing some buttons, all right? And if you've done the linear regression right, you're always going to get out three things: a slope, a y-intercept, and you want to have some way to find what's called the correlation coefficient. If you look at A and B, the graphs on the left side, you can see that the first one, A, has an R equal to +1, and on B, the R equals -1. The correlation coefficient just says how good your slope and y-intercept match with the actual data. And if the actual data and the line that's created from the slope and the y-intercept are matching perfectly, then you're going to have R equals +1 if the slope is positive, and you're going to have an R equals -1 if the slope is negative. So the sign of R, little r, will depend on the slope. And if your slope is negative, then little r will be negative. And if your slope is positive, little r will be positive. So a slope and a y-intercept are what people use to describe a line. And again, if this has been a while since you've thought about it, you can have the expression y equals ax plus b. A is the slope, and and b there would be the y-intercept. So A is the rise over run, like how steep, if you will, the line is. B is where the value actually goes through the y-intercept when x equals 0. If you have the slope and a y-intercept, you can describe a line in any way you can. R is really helpful for chemists because the better the R, the better your data corresponds to the slope and y-intercept that your program has calculated. If you're lucky, and especially if you have a calculator, you very well might get the little r out directly. But most of the time in Excel, numbers, sheets, and these kind of things, for whatever reason, they almost always give you r squared, and they capitalize R. So one thing I want to highlight right now is that little r can be quite different than big R. Big R is little r squared, all right? That's why they call it r squared. So if you're using a program that gives you r squared, the capital R squared, it's easy to turn r squared into little r, but there's two things you have to do. You have to take the square root of r squared. Square root of r squared would be just r. But the other thing you have to do is you have to correlate the r with the slope. If your slope is positive, like graph A there on the left-hand side, then you don't have to do anything. Little r is going to equal square root of r squared. But if you have a graph like B, picture B there on the left-hand side with a negative slope, then your little r is going to equal negative square root r squared. Remember that -3 squared is 9, so a negative number squared is positive. And I think that's why these programs like to give you r squared, because the r values are always positive that way. But if you want the little r, you do have to take into account that you can have a positive or negative value. So negative slopes will give you negative little r, positive slopes will give you positive little r. And you can translate r squared back to r doing that. It's not too hard. So in graph A and B, in A, if we were given r squared, then r would just equal the square root of r squared. And we don't need to do anything because, again, the slope is positive. But on B, if we were given r squared and we wanted to get little r would equal negative square root r squared. Little r would be a negative number because the slope is negative. In this video, we're going to see how to do a linear regression in Microsoft Excel. And this is the version that I have on my Macintosh. Every version of Excel I've found has been a little different from the last one, but they all do have similar elements. So this is how you do it with this version, and we'll talk about some ways how you can use linear regression in other versions. You should do the linear regression on a computer-based Excel. The online online versions and also the like iPhone and Android versions usually don't do linear regression. So I'm just letting you know that as well. Anyway, what you can do is, first of all, put up your X data in the X column and your Y data in the second column. So notice X first, Y second. And then what you can literally do is just select the data, all right, like I've done right there. And again, this is where it gets a little different, but you want to insert a chart, and there's different kinds of charts. In the best world, you would have the XY scatter chart. So I'm just gonna click that, and then some options come up. You ideally don't want to have any lines between the points, which the other ones do. If you do, it's not the end of the world, okay? But it's best to just have them as points. And if you click it, you'll get something like this. Now let me make this a little bit bigger. Now in my artificial data, it's not quite linear, but it's pretty linear, all right? And you can see that the Y values go up to about 12, which is here. The X values go to 5 and stuff. Pretty cool. Now you can make this graph as fancy or as lame like this as you want to, all right? As long as you tell me what's going on, honestly, it's okay. But to get the linear regression, and this is the important part, usually what you do is you just click on the points, and sometimes you have to right click. Now on my Macintosh, that's a control click, but either way, when that happens, there's going to be something about a trend line. You want to add a trend line in whatever version you're working on. So I'm going to click it. Some stuff pops over here, and you can see that linear is selected. That's good. But the important parts and the money makers, display equation and display R squared value. This little thing right here is what you need. The first part on the top there, y equals 2.5x minus 0.9. The 2.5 is the slope, all right? And the y-intercept is what follows the x. So in this case, the y-intercept is minus 0.9. And then under that, we have the R squared value. Now, R squared is not the little r, the correlation coefficient you want, but it's easy to translate one into the other. So in this program, R squared 0.9889, what I would do to get little r is I would first take the square root of something squared is itself. So square root of R squared, and because this is a positive slope, i.e. it's increasing up and to the right, and i.e. the slope itself is a positive number, then I do not need to add a negative sign. Literally, the square root of R squared in this case equals little r. So Excel does not give you little r exactly, but you can easily translate it. Positive slopes equal positive little r. We'll see an example here in a little bit of when you could have a negative little r. This is a demonstration of how to do a linear regression in Apple's Numbers. Numbers is a program that comes free with Macintosh computers as well as iPhones and iPads. I do recommend that you use a regular computer version of Numbers when doing this. I've found that a lot of times the iPad and iPhone versions do not do linear regression. They'll make a nice graph, but they won't actually do the linear regression, so you may have to use the computer version. Anyway, how this works is you have data and you set it up in columns, all right? And I have just here random data, X data in the first column and Y data in the second column. And I do recommend putting X first and Y second. But anyway, what you can do then is just select the data like I've done right there, and then you want to insert a chart. And if you click on the chart up here, there's lots of possibilities and colors, and you can pick the colors, but the one you want to try to use is this one right here. This is called a scatter graph. And if you click on it, this is what you see. Let me make it a little bit bigger here. And you can change the XY values and the fonts and subheadings and all that kind of jazz. I don't really care about that as long as you let me know what's going on. To get the linear regression, which is the reason we're doing this, you want to click on the points. It might be a right click, but definitely, like in this case, it's just a regular click. And then over here on the right with this version of Numbers, and again, this is September 2020, so future and past versions might be a little bit different. But anyway, you want to have a trend line. Trend line is a way you can do some analysis, some regression analysis, and we want linear regression analysis, so select the linear. But the most important parts, you want to show equation and show r squared. So this first part up here on the top, this is the equation with the slope and the y-intercept. And the slope is negative 2.5. It's whatever is in front of the x. And 14.1 is the y-intercept. Now, numbers like Excel and most of these programs don't give you the correlation coefficient, the little r, by itself. They give you the square of the correlation coefficient. But scientists, for whatever reason, like the little r better. So it's easy to translate an r squared into an r. What you would do is you would first take the square root, 0.9889, and that's going to be a number. And second of all, if you have a negative slope, and we do here, you want to put a negative number inside it, all right? So whatever the square root of 0.9889 is, put a negative in front of it. R is going to be a negative number. Negative slopes, slopes that quote-unquote increase up and to the left, have negative r's. So it's a nice way, and you can mathematically see that by the value of the negative there, negative 2.5. The negative shows it's a negative slope. So again, if you don't have this exact version, or if you're using another program, it's totally fine. It's usually looking for a trend line, okay? And what I would do if you're using a different program is go to like YouTube or something like that and enter something like Microsoft Excel 2015 linear regression. Do a search for that if you're using, of course, Excel from the 2015 version. Almost always a video will pop up which shows you how to do a linear regression for your version, and that's a really cool way to get this done. It's almost always about finding a trend line, and again, I do recommend you put the x values first and the y values second. In this lab, what you're going to do is you're going to have 4 problems, and in each of them, you're going to have sets of data that you'll need to graph. And so make a nice computer-generated graph. Don't give me any hand-drawn stuff, okay? That will be part of the assignment that you're going to turn in. And with the data that you're going to graph, you should also do a linear regression on each set of data. And again, when you do a linear regression, all right, you should end up with a slope, a y-intercept, and that little r, that correlation coefficient, all right? There's usually a question or two then relating to the linear regression. They shouldn't be too bad or anything like that. I think I do recommend using a program like Excel or Numbers or Sheets just because you can not only graph, but you can get the linear regression out at the same time, all right? On the other hand, if you want to graph with one program and do the linear regression with another program, that's fine. Just make sure that you record slope, y-intercept, correlation coefficient, and you'll be good to go. Again, just want to highlight that I'm really hoping this linear regression problems will be pretty chill, all right? The first one is a little weird sometimes if you haven't done it, but once you do it and stuff, it should be pretty chill. If you do get stuck, or if you have a program that I'm not talking about that you wish to do linear regression on, honestly, that's fantastic, all right? YouTube is a great source of how-to linear regression videos, and I mean that sincerely. I've used them myself, Secrets of Instructors 101, but anyway, yeah, don't be afraid to go there and check it out. And also don't be afraid to reach out to me or the Learning Success Center, Avid Center. Doing a linear regression is actually fairly common, and it shouldn't be too hard to figure out. And then finally, one more thing. A lot of the iPhone, Android versions of these programs, or even the Office 365 online versions, they won't do linear regression. And I have no idea why they're not including it. I guess they don't think we're cool enough or whatever, but you may have to use a PC version or your calculator to do the linear regression. So if you are using the iPhone version of Numbers, for example, the last time I checked, it did not do linear regression. So if you get stuck, all right, you may have to jump ship and go to linear regression on a PC or a Mac or something like that. If you don't have access to a PC or a Mac, there are websites that will do linear regression for you. And if you reach out to me, I can send you one of them. So don't feel like you have to have a computer, but also don't rely on your iPhone, Androids, iPads, or even Office 365 online. You may need something with a little bit more hardcore power. Okay, I think this is a good place now for you to start working on the lab. If you have any problems graphing or problems with the linear regression, etc., please let me know or contact the Learning Success Center / Avid Center. All of us are here to help you, definitely. Also, if you're at home and you're not next to anybody, you can also search YouTube for videos on how to do linear regression or graphing for that matter. It should be a pretty easy process. All right, good luck with your lab. Let me know if you have any questions and have a great day.